This is my really high-tech demonstration of GPS. What I'm going to show is how knowing the position of 3 satellites, which are represented by the bosses on these clamp stands, 1, 2, 3, and our distances from those satellites, represented by the string with a bit of blue tack at the end, can lead to us knowing our location and why we need 3. In reality you need 4, but you'll get the idea by showing 3. What we know is our distance from the satellite, and the reason we know that is that a signal is broadcast from the satellite with a timestamp on it. So we know when the message was sent, and then at the receiving end we know when we received it. So we know how long it took for the signal to travel from the satellite, whose location we know, to us. Because we know how fast the message travelled at the speed of light, because it's radio waves, then we can work out how far we are from a satellite. So if I know the position of this satellite and I know how far away I am, which is represented by the string, then I could be anywhere that is that distance away from the satellite. So it could be here, could equally be over here, up there, down there. It could be anywhere. In fact, it could be anywhere on the surface area of a sphere with a radius equal to the length of this string, because that's the number of possible places that I could put the end of this string. Now that's a lot of possibilities, so we need to narrow it down. Let's bring in a second satellite, this one over here. Now, same procedure, I know my distance away from that satellite, whose location is known as well. So I could be this far away from that satellite, but I also know I'm this far away from that satellite. Got to keep the strings taut here. So let's go on this side of it. We must be where the 2 strings meet. Okay, so it could be there. Now I have narrowed it down, but let's just see by how much I've narrowed it down. Well, there's a number of places where these 2 strings meet. There's another possibility. In fact, I can go all the way around in a circle. So I've gone all the way around in a circle there. It's just getting wrapped around the box there. So what I've done is I've narrowed my possible number of locations down from the surface area of a sphere to the perimeter of a circle. That's still not enough to get me the one place. Let's bring in a 3rd satellite, whose location I know, and I know my distance from that satellite. So this string now combines with all the others, and I've now narrowed myself down, not quite to one position, because although the strings are taut there, I can also move them up here. So I've actually narrowed my possible locations down to 2 positions, but that's pretty good. Now you could theoretically work out your location from there, because one position is down here, and that would likely be the surface of the Earth, and one position will be up here in space. So I could use that to ascertain my position on the Earth's surface, and that's the amount of information you need to know for explaining GPS in the exam paper. In reality, you use 4 satellites, and that would actually give you enough information to work out your altitude as well. So that's trilateration, the method of trilateration and how it works, shown with a 3D representation.